All right, let's start. Okay, now for the first chapter, this is physics, right? Okay, for the first chapter, you guys are gonna learn physical quantities and measurements. Benda ni memang direct je, like super direct, tapi it's very important for you guys to know how to interpret SI units, symbols, and all those stuff. Okay, with this knowledge, you're gonna go further for chapter 2 sampai chapter 5. It's gonna help you a lot. Alright, this is the chapter which teaches you the basics of almost everything. Okay, let's start. Now, in physical quantities, the first thing you guys are going to learn is, let me just pick a color, dimensions. Now, what is the basic concept? Yeah guys, if ada apa-apa, just stop me, okay? Alright, what is the basic concept of dimension? Dimension is not like, 3D, 2D, 4D or whatsoever, no. The basic concept is actually capitalization. Okay, capitalization, kalau dalam bahasa Melayu, kita cakap huruf kecil jadi huruf besar. Okay, tapi untuk dimension, they work a little bit differently. Untuk dimension, let's say M, that will become M. Tapi, this is true, but not whatever you guys see here will turn into capital letter. Now, what will turn into capital letters? The first ones, the first letters of the spelling. Now, benda ni semua adalah all these measurements. You guys know these physical quantities. Dulu dah memang belajar. Okay, right now I'm gonna ask you guys questions. Please turn on your mic and answer me. Okay, now, what is the SI unit for mass? Anyone? SI unit for mass?
Kilogram.
kg,
Yep, kg. Next, what's the SI unit for length?
Meter.
Okay, meter. What is the SI unit for time?
Second.
Second.
Okay, electric current.
ampere,
Ampere.
Clear, very true. Next, temperature.
Kelvin.
Kelvin.
Yep, Kelvin. And next, amount of substance.
Mole.
Yep, mole. Okay, benda mole ni you guys will learn quite deep in, you guys will learn quite deep in chemistry. So don't worry. Okay, untuk physics, right, the most important ones are 1, 2, 3, 4, and 5. Yang ini, amount of substance or mole is not exactly very important. Soalan majority is from all these first 5 things first. Mass, length, time, electric current, and temperature. Okay, now, you guys have learned the SI units dari dulu lagi. But now, when we talk about dimension comes in symbol. So, what did I say? It's capitalization of whatever you guys spell out here. But it only represents your first letter. Maksudnya dalam mass, M kecil akan jadi M besar. Length, L kecil akan jadi L besar. Time, T kecil akan jadi T besar. Electric current, what about electric current? Any ideas?
I
Yep.
besar.
I besar. Okay, before we go further, why do we say electric current I besar? Anyone? Korang pernah tengok formula ni kan? Sorry, V equals to IR.
Yes.
Okay. I ni apa?
current,
Yep, exactly. I is the electric current and it's capital or not? Yes, it's in capital letter. So that is why they choose I as the dimension for electric current to make your life super simple. So that lepas ni masa korang masuk SEM 2 ada this kind of formulas, right? You guys know directly, okay, I is definitely going to be electric current. Benda tu further details in SEM 2. SEM 1 we're going to learn all this stuff first. Okay, next. What about temperature? What is the symbol for temperature?
T,
No. For temperature, it's a little bit special. It's theta. Sorry, it's theta. Okay.
T.
It's not T capital, it's theta. Yang ini, simbol ni kan korang guna untuk math semua, tangent theta and all those stuff. Yeah. Untuk physics, temperature, the symbol atau dimension untuk temperature is theta, okay? Alright. Now, kenapa theta? When you guys see dalam, what do you call that? Thermometer kan detect temperature. So everything is in degrees Celsius, right? So, dalam degree Celsius tu, the idea they got revolutionized, maksudnya ikut zaman. You don't expect them to keep on doing this because dimensions are usually something which is simple. Something which is simple and direct. So, they turn temperature, the dimension for temperature into theta. And kalau nak guna T, you guys akan langgar the rule of time. Takkan. Then how do you differentiate this T and this T? This is for temperature, this is for time. No, it wouldn't make sense. So that's why they focus on theta. Next, amount of substance. What is the symbol of the dimension? Anyone?
N.
Yeah,
N.
that's a good one. Okay, now dua ni actually, honestly, korang perlu tahu tapi don't focus too much. Yang korang kena focus is these four. These four memang akan selalu guna. Okay? Mass, length, time, electric current. Okay? Alright, that is dimension. Remember, the basic idea of dimension is actually the capitalization atau huruf besar, huruf kecil pergi huruf besar. And bukan huruf kecil untuk SI unit ya. It's huruf kecil untuk ejaan kepada physical quantity tersebut akan menjadi huruf besar. That's the basic idea. Okay? Now, let's move on to the second part. Alright. Okay. Now, velocity. Okay, what I want you guys to do right now is search dalam Google ke, or if you guys know, quickly tell me what's the unit for velocity.
Meter square.
No, meter square is area. Velocity.
Meter per second.
MS
Yeah,
-1.
meter per second atau ms -1. Next, acceleration.
Meter square. Meter square.
Meter.
ms to the power of -2.
Yeah, meter per second square or ms -2. Momentum. Korang boleh search Google juga lah.
Kilogram meter per second.
Yep, kilogram meter per second atau kg ms -1. Density.
Newton per meter square.
Okay, you guys can derive it into smaller quantity. Remember, unit dalam physics SI unit, okay? So basic SI units are kilogram, meter and all that. So what is the basic density unit? Lebih basic daripada tu. Tadi someone said what? Newton
Over meter square.
Newton over meter square. Okay. Now, what do I mean by basic? Newton tu apa? What is the unit for Newton?
Force.
Okay. Force, what is the SI unit?
KGMS -2.
kgms -2. Okay. Now, kgms -2 per m square. kg m -1 s -2. Is this the unit for density? Kalau korang tak faham, what is the definition of density? Ini benda ni science form 3 dah belajar dah. Definition of density. Guys, derivation memang paling penting.
Volume.
Pardon?
Mass over volume.
Okay, mass over volume. What is the unit for mass? SI unit.
kg,
G. Volume?
liter,
mg.
gram.
M
kg, SI unit ya. So keep it kg over m power negative 3. So kg m negative 3. Ini barulah unit atau SI unit kepada density. This thing is wrong. Okay, please take note. Derivation yang ini semua sangat-sangat penting, okay? Because we want to know, okay, let's say you put n here. What is n? Unit for force. What is force? Mass times acceleration. That is how you're going to derive slowly into the paling basic SI unit. Baru korang boleh tukar pergi dimension, whatever we have learned. Sebab dimension only works whenever you have paling basic SI unit, okay? Alright, next. What is force? Yeah, now force. What is the basic unit for force?
kg ms negative 2.
Yep, kg ms negative 2. Alright, right now, untuk buat dimension, you guys must know not this, but all this, and this. Okay, right now, I need answers from you guys. What is the dimension of velocity? Remember, m over here, we have learned m length kan? You guys just convert dia pergi L. Tadi S is the SI unit for time kan? You guys just convert it to T. So, in here, what do you think will be the dimension of velocity?
v
LT minus 1.
Yep, LT negative 1. That's the basic idea. Kenapa? L is length. SI unit untuk length adalah meter. Tapi untuk dimension, we cannot use meter. We have to change it to the physical quantity. Meter, length. Then you capitalize atau jadikan L dalam ejaan length tu kepada huruf besar, make it into L. Same concept for T. Kenapa? Because T is for time. SI unit second. You don't take S, you take physical quantity, which is time, change it into capital letters, you'll get T. Negative 1, maintain. Kenapa? Numbers are not involved in dimension. I repeat, numbers are not involved in dimension. Okay? Alright. Now, what is the dimension for acceleration?
LT negative 2.
Exactly, LT negative 2. Guys, siapa-siapa tak faham, just stop me, okay? Now, what is the dimension untuk momentum?
LT minus 1.
M
LT.
MLT negative 1. You mean this one? Kilogram SI unit for mass. Capitalize mass, you'll get M. Meter SI unit for length. Capitalize length, you'll get L. Second SI unit for time. Capitalize T, you'll get T. Negative 1, maintain Y. Numbers not involved. Next, all right, good. Next, density. What is the SI unit? What's the dimension for density?
ML minus 3.
Yep, correct. Next, what is the dimension for force?
MLT minus 2.
Yep, MLT minus 2. Okay, these are the common paling direct they will ask. Okay, memang paling direct they'll ask velocity like this. Okay, now to make things complicated or to make sure you guys think to get marks, questions won't be this direct. Questions will ask you a little bit differently and a little bit complicated. Now, this is just the basic concept. Okay. Let me introduce to you a couple of symbols first before we go. Yang baru-baru, I mean, some you guys PDT memang dah belajar dah. Just refreshing, and those who yang tak pernah belajar, let's learn together. Okay. A is for acceleration. Okay. A is the symbol, not symbol lah, it's actually a representative. Dia represent acceleration. Kenapa dalam calculation nanti you guys can see formulas like this, A and all those stuff. Because kalau you talk about symbol, it's going to be dimension, it's going to be symbol for SI units. But A is a representative. Don't get it wrong, because soalan when they ask symbol means they want symbol. They don't want anything else. Okay. U is your initial velocity. V is your final velocity. Benda ni we'll learn extremely detailed in chapter 2. S is displacement. T is also known as time. Okay, these are the basic things that you guys need to know in order to master chapter 2. Chapter 2 is extremely technical and extremely detailed. Angles, calculations, vectors, scalars, everything will be there. Okay, now, to make your life tough, number one, what they'll do is they will substitute whatever you guys learn initially kan kepada symbol macam ni. U, T, T, S and all those stuff. You guys kena faham sendiri. Okay? Number two, they will use the term homogeneity. Okay, apa maksud homogeneity? Homogeneity which means belah kiri sama dengan belah kanan. Then only it's equal. Kalau tak equal, we call it non-homogeneous. Okay? Homogeneity is very, very important. So that you guys, majority soalan homogeneity lah. Homogeneity and dimension. This one memang akan ditest in your question number 1, Sem 1 paper. Okay? Right. Now, let's do this question together. Let's test whether soalan dia homogeneous or not. Now, 2S equals to 2UT plus AT square. Okay, S, displacement kan? What is the dimension untuk displacement? Anyone?
L.
Just try. Pardon?
L maybe.
Yep. Okay. Displacement, you calculate displacement. You guys know what is distance kan? Distance, you guys know clearly, korang calculate guna meter. So it becomes M, becomes length, and it becomes L. Okay? Displacement adalah just the vector of distance. Vector dengan scalar we'll learn very shortly, okay? Now, so when S is over here, can I just remove the 2 outside? I said numbers are not included. So what you're going to do is you got to put S. Okay. Reminder over here, the symbol for dimension is brackets. This bracket is the one have the power to capitalize, any letters, okay? Tanpa bracket ni, korang tak tunjuk bracket ni, salah. 0 marks, okay? Next, you have to remove the 2 again. U, T, plus. Bracket A, T, square di luar, okay? Now, korang tak boleh buat ni like mathematics, push this there, push that here, no. You guys have to prove whether it's left hand side equal to right hand side or not. Now, an easier way for you to do this is just write kat sini left hand side and then do 2S. You guys will get 2L. Then you do right hand side. When you want to do right hand side, okay, buat satu-satu dulu. What is U? U is initial velocity. Tadi kita dah belajar dimension untuk velocity. What is the dimension for velocity?
LT -1.
Okay, LT -1. What is the dimension for T?
T.
Yup, capital T. Okay, korang realize tak? Lepas bracket macam ni, you guys have to put it in this kind of brackets, normal brackets. Kenapa? This process is called multiplication. T power -1 times T. You can cut it off. Kenapa? It's basically T over T. When you cut, equals to 1. So you will get 2L over here. Next, plus. When you plus, it's AT square kan? You have to bracket A T square di luar. Alright. Now, what is the dimension untuk acceleration?
LT -2.
Okay, LT -2. What's the dimension for T square?
T square.
Yep, T square. Can you guys cut? Yes, we can cut. So, we're gonna get plus L. Okay? Yep, sekarang 3L. Okay, now you guys can clearly compare over here. Let's just translate this whole thing. Answer dia dekat sini, okay? So, we're gonna get dimension dia 2L equals to 3L. In your opinion, jawapan dia homogeneous or not?
No.
Tidak.
Uncontinuity.
Why
No.
do you think so?
Sebab kiri dan kanan tidak sama.
Why homogeneous or why not homogeneous?
Sebab left hand side sama right hand side-nya tidak sama.
Okay, itu memang clear boleh nampak, okay? Adakah anda rasa ni homogeneous in the sense of dimension atau tidak? And kenapa?
Dimension, yes, because both have L. Only L.
Yep, exactly. So, do you guys think these two are homogeneous or not?
Yeah.
Yes, exactly. Now, why do I say so? Kan mula-mula sekali I dah cakap, is number involved?
No.
When number is not involved, what you have to see is the dimension je. Let's say dekat sini kan ada plus M, baru it's not homogeneous. The moment there's L over here, and there's no plus whatever or LT -1 or whatsoever, the moment there's only L and L or M and M, it's completely homogeneous. Okay? Remember, kiri dengan kanan kena sama. Alright. Now,
So maksudnya, mau tanya.
yeah, sure. Just ask. Maksud dia?
So maksudnya yang ditengok dia punya dimension je akan mesti sama.
Yes, tengok dimension je. Dimension dia datang daripada physical quantity. Physical quantity datang daripada SI unit. And SI unit dia datang daripada representation. These are all the representation. That's why everything is related. Tak tahu satu, you guys will lose the flow. Okay? Next. Any questions before we move on? Okay, sikit je lagi. Alright, next. Scalar and vector quantity. I think many of you guys have learned this. Please tell me what is scalar quantity.
Have magnitude only.
Okay, atau magnitude or direction only. Okay guys, yang ini memang sangat penting. Dulu masa SPM memang not so important. But right now I tell you this is very important. Kenapa? You guys will lose banyak sangat markah kalau tak tahu ni kena letak negatif ke, ni kena letak positif. Positif you guys can be safe. Tapi negatif masa masuk, your whole calculation will be crash. So please make sure you guys know what is scalar, what is vector. Okay, next. Remember or atau. Maksudnya salah satu je kena ada. Next, vector. Vector ada dua-dua. Magnitude and direction. Okay, now let's analyze this situation right now. You guys think this is, which one is vector, which one is scalar? Mana satu?
The vector one. The vector
Yang di
one.
atas vector.
Yes.
Okay, you guys see vector. Bawah ni?
Scalar.
Okay, you guys see bawah ni scalar. Okay, to me, right, these two can be vector quantity, can be scalar quantity. Tahu kenapa? There's no need for you to represent positive in any ways. Tak ada positif ni pun dia boleh jadi vector, dia boleh jadi scalar. Please bear that in mind. Tapi, compare yourself with a situation like this. Bila ada negatif terang-terang kat sini, it automatically becomes vector. Kenapa? We have magnitude. Magnitude is amount, 1, 2, 3, 4, 5 or whatever. And then we have direction over here. Okay, negative goes where?
Left.
Left. Okay, left dengan?
Down.
Yep. Whatever going left and down is negative. Whatever going up and right is positive. This one is very important for your chapter 5 and chapter 4. Chapter 4, chapter 5 memang penting sangat. Whatever going up and right is positive. Whatever going left and down is negative. Okay. Now, in this case kan, jangan risau. They won't give any kind of situations like this because they know it's never going to happen. Don't worry, it's never going to happen. This kind of case, you guys have to take note. Yang ada positif, yang ada negatif. Okay. Now, because yang ini kan, it's speed. Yang ini, speed. Tapi, yang ini boleh jadi velocity. Yang ini boleh jadi velocity. So, the moment it's speed, it's one type of quantity. The moment it's velocity, is another type of quantity. Okay? Now, let's go on to scalar or vector quantity. This is where you'll examine yourself whether you understand properly what's vector and scalar. Now, benda ni semua, why did I write it like in pairs? Because these two are like benda almost sama and always people confuse it, which is scalar, which is vector. Now, distance, do you think it's scalar or vector?
Scalar.
Okay, what is the unit for distance?
Meter.
Okay. What is the dimension for distance?
L.
Okay. Displacement, scalar or vector?
Vector.
Okay. What is the unit for displacement? Guys, tadi kita dah bincang, what is the unit for displacement?
M.
M, okay, meter. Dimension?
Also L.
Alright, also L. Now, give me, this is the part, okay? Please bear in mind. Give me the example of distance. Apa-apa value lah, bagi je.
100 meter.
Okay. Give me an example of displacement.
Plus 10 meter.
Exactly. Now you get my idea. Or you can put it as negative 10 meter juga. Okay. This is your chain flow yang you guys cannot ever leave untuk SEM 1. SEM 1, everything is about all this stuff. Okay. Now, that is distance versus displacement. Let's take a short, direction. Kalau yang ini, distance from this point to these points. Kalau distance, you guys will go here and then you guys will go here. The longest route, okay? Or the given route. Kalau displacement, as usual, I think we all know, we'll just cut through the shortest route. This one you guys will learn in chapter 2 in detail, definitions and all those stuff. Okay? Now, let's go to the next one, speed. Scalar or vector?
Scalar.
Okay. What is the unit for speed?
ms -1.
Correct. What is the dimension for speed?
lt -1.
Alright, correct. Next, give me an example of speed. Come on guys, anyone?
20 ms -1.
Okay. Next, velocity. Scalar or vector?
Vector.
Okay. Unit for velocity?
ms -1.
What is the dimension?
lt -1.
Okay. What is the example of velocity?
-2 ms -1.
Alright, correct. This is your chain flow. Now, let's move on to work. Scalar or vector? Okay guys, in learning process, you guys nak tengok, rujuk, Google to answer me pun boleh. Don't worry. Yang paling penting, we learn. Okay? Next, what is the scalar or vector work?
Scalar.
Okay.
Scalar.
What is the unit for work?
kg m2 s -2.
Okay. kg m2s -2. Now, work adalah apa darab apa?
Force and displacement.
Okay, force and displacement. Force tadi is equals to ma. Mass times acceleration. So kg ms -2, that is force. Now, darab displacement. kg ms -2 darab dengan s. So you'll get kg ms -1. Okay? Atau the easier version is what? Work.
Joule.
Yeah, exactly. Now, what is the dimension for work? This one you have to do your calculation. Come on guys, quick.
ml2 t -2.
ml2 t -2. This kg ms -2 darab dengan force times displacement kan. Force is, let's just do the working over here. Force times displacement. You get force is ma. So kg ms negative 2 darab dengan displacement which is m. So you will get kg m square s negative 2. So kg mass, m square length, s negative 2 time. Okay? Give me an example of value. Any value.
Seven joule.
Yep, 7 joule. Simple as that. Okay. Now, kenapa you guys can see over here kan? This is vector quantity, this is vector quantity. Kenapa work is a scalar quantity? Sebab number one, there is only magnitude, and number two, dot product between vector quantity and vector quantity equals to a scalar quantity. Please take note of that. Tapi kalau you guys don't know dot product between vector quantity and vector quantity equals to scalar quantity, no worries, as long as there's no negative or positive over here, definitely is going to consider itself as a scalar quantity. Now, kita dah buat untuk force kan tadi. So, as simple as it is, force is a vector quantity. What is the unit for force? kg.
Newton.
Alright, you can use Newton juga. And what is the dimension of force?
ml t negative 2.
Alright, negative 2. Okay, any examples of force? Let's say we put negative 5 Newton. You can actually put 5 Newton, you know. Alright, highlight over here, force kan, we learn positively, no negatively. Tapi, this is for chapter 1. Chapter 2, any possibilities, and chapter 4, any possibilities will occur. But we learn force in chapter 1, positive. No matter what, because we only know Newton kan. So when we know Newton, we relate it to this. The moment we relate it to this, we know it's a vector quantity and force is a vector quantity. Okay? Chapter 4 punya possibility. Chapter 4 is forces. That one we're going to learn very detailed. Okay? Next. Now we're going to learn on, let me choose a bit. Alright. Time. Time over here, as simple as it is, scalar or vector.
Scalar.
Alright, scalar. Time is scalar quantity. What is the unit for time? I think this one is it's okay. S, and then you'll have t dimension for time. Let's say example is 3 seconds. Okay, this one is very quick. Now, acceleration. You guys have learned too. Acceleration is a vector quantity. Now, the unit for acceleration is ms negative 2. You will have a dimension of lt negative 2. Example of acceleration 3 ms negative 2 or negative 3 ms negative 2. Alright? Any questions before we move on, guys?
No questions.
Alright, thank you. Scalar vector sangat penting ya. Chapter 1 might be very direct, might be okay, this thing is okay, normal thing. Masuk chapter 2, until end of the syllabus, then you guys will know benda simple ni akan affect small calculations. Alright. Now, I'm going to teach you resolving vectors. This one is very important, especially for chapter 2, 3, 4, 5. Resolving vectors. Apa benda resolving vectors? Okay. Now, let's say they were to give you a force at this direction. They ask you to calculate how much it is. So what you have to do is, you can't be simply calculating whatsoever tambah-tambah dapat ni. No. You have to take the y component, x component, resolve dia, baru akan dapat ni. Okay. Now, how to do so? Let's say over here, we have v. Okay, atau r or apa x or whatever lah. Let's try to remove x sebab we are going to focus on x and y component. Okay, the moment they're talking about X and Y component, apa benda tu? X component is this one, Y component is this one. Okay, please concentrate here, okay? Let's say dia bagi angle dia dekat sini. Angle dia theta. Okay? Atau let's say angle dia 30 darjah lah. Okay. Untuk cari X component, what you guys have to do is guna cos atau sin. Anyone knows this? Do you guys have to use cos atau sin untuk cari X component?
Sin.
Okay. I'm sorry but it's wrong. Untuk cari X component, you have to use V, which is over here, whatever value, cos theta atau V cos 30 degrees. Automatically, Y component V sin theta atau V sin 30 degree. Alright, now, why is it so? Benda ni is paling penting. Kenapa all this stuff is so? Now, korang tengok Y dengan X kan? Over here is theta kan? So, cos is what? Adjacent over hypotenuse. Adjacent is whatever like this, hypotenuse is like this, the longest side. Okay? Now, dalam case ni, let me choose another color. Okay. Dalam case ni, Y, X, theta. Okay. You have to use V cos theta. Kenapa? V cos. Cos is adjacent over hypotenuse. V cos theta. Theta, whatever angle put it in, cos is adjacent over hypotenuse. If I were to translate this, V adjacent over hypotenuse theta. Adjacent, you kena cari. Hypotenuse sudah ada dekat sini. This is your hypotenuse, your V. V, value of V. Okay. Right now, you want to find what is X component kan? So, when you want to find what is X component you guys know yang mendatar dekat sini. The moment mendatar dekat sini, adjacent. That's why you guys use cos dekat theta. Basic idea is as simple as you taking a triangle. Theta dekat sini, let's say sini 5. 5 cos theta is the value dekat sini. Okay? 5 sin theta adalah value dekat sini. Kenapa? Cos adjacent over hypotenuse. Sin opposite kepada angle ni over hypotenuse, which means you dah ada whatever value dekat sini. Nak cari cos theta atau X component is adjacent punya value. Nak cari sin theta atau opposite punya value adalah this one, Y component. Okay? Do you guys get the idea? Kalau tak dapat, please stop me and ask. Sebab benda ni memang chapter 2 100% akan keluar. That is the trick for chapter 2. Any questions for this? Alright, I think I'll explain to sign. Now, Y kalau dekat Y component, this is X, this is Y, theta over here. Y kalau dekat Y component, you must use sin. Simple as it is. Let's take a triangle. You have the angle theta. Y dekat belah sini ke, Y dekat belah sini ke, let's say Y dekat belah sini ke, atau Y dekat sini, it's just the same thing. Dua-dua benda sama. Because the area atau kawasan straight line ni adalah sampai sini je. Dia tak akan exceed the thing. Okay? Dia akan sampai sini. So the moment sampai sini and you include the angle, which means Y dekat sini and Y dekat sini, value dia akan sama. Okay, that's number 1. Number 2, kenapa sin? Sin is also equals to Anyone?
Hypotenuse.
Alright,
Hypotenuse.
opposite over hypotenuse. Right now, you don't want to find x component. That's why you tak guna cos. Kalau tidak, cos akan jadi adjacent. Right now, you want to find the y component dekat sini. That's why you use opposite. Angle dah ada. So, opposite kena cari. Hypotenuse sudah ada. Value of v tadi. Substitute everything, you'll get what is your opposite. So, what is your opposite is actually your y component. That is how you resolve vectors. Itu baru you boleh dapat jawapan sebenar V ni. Okay. Now, please take note. Yang ini dengan yang ini lain tau. This one can be 3 meters, this one can be 5 meter walaupun direction sama. Direction sama, magnitude berbeza. That is all about vectors. Direction and magnitude. Okay? Direction sama, magnitude berbeza. Alright, don't get yourself confused. Any questions before we move on?
No questions.
Alright. Next, the last part of this chapter. Magnitude of vector. Okay, tadi I cakap resolve, right? Resolving vector tadi, you dah cari the x component, the y component. Nak cari hypotenuse, guna Pythagoras theorem. Atau nak cari the official atau the real value of r atau v atau v or whatsoever, guna Pythagoras theorem. Nampak tak sini? X component, you have to take apa yang you dah resolve tadi, x component. Masukkan value dia square. Ini ry, y component punya value, you dah cari tadi melalui sin theta, you akan dapat value dia, square dia, square root Pythagoras theorem, you'll get the value of r. Okay, the value of r over here is only your magnitude. Tapi dalam soalan dia cakap velocity. Velocity is a vector quantity. So, you have to find your direction. Macam mana nak cari direction? Untuk physics, mainly they will use cara ni je. Direction, tangent theta, ry over rx. Now, tadi I cakap apa? Sin and cos. Now tangent. Tangent is opposite over adjacent kan? Tadi kalau you guys remember, opposite is like this, adjacent is like this. So, does that relate very well? This is your y component, this is your x component. Do you guys get the idea right now for tangent theta?
Yes.
Okay. Now, masa dapat direction ni tangent theta, you have to use this one. Lepas tu inverse tangent belah situ, masukkan value dalam calculator, you'll get what is theta. Theta is the angle between it. Okay. Now, you have to say kenapa angle ni penting. Let's say 30 degree to the right. The moment that's to the right like this, that is the direction. Jangan risau pasal ni sangat. You guys have to know basic concept je. Make sure you guys understand dia dulu. Sebab benda ni kita akan guna masuk chapter 2. When you guys see real life examples yang kita buat lepas ni, baru you guys can relate. Oh okay, this is when you use tangent theta and all those stuff. For now, you guys have to know, paling penting chapter 1, SI units, prefix yang saya telah hantar tu, mesti kena faham and mesti kena tahu. And number 3, scalar or vector quantity. These 3 are the most important ones. Dimension, scalar quantity, vector quantity, and prefix. These 3 are the most important ones. Okay? Yang ini, you guys know or don't know, at least faham something. Because lepas ni, benda ni semua soalan akan keluar like this. Okay? Now, the moment they ask, what is the magnitude only, then you give value je. The moment they ask, what is the magnitude and direction of something, then you give both of them. But when they ask what is the velocity, you guys know very well velocity is a vector quantity kan? So you have to include magnitude and direction. Kalau ditanya what is the speed, hanya magnitude. Kenapa? Speed is a scalar quantity. So now, do you guys understand right now? Or you guys have any other questions, please ask me right now. Okay, so now we'll go on to my last ever point note for this chapter is to find velocity only, as I've said just now. The moment they say dia tak cakap apa-apa, velocity you know is vector kan. Tapi kalau dia tak cakap magnitude depan ni, you have to resolve and give the magnitude and direction. The moment dia cakap magnitude je of velocity, then you only give the magnitude. Okay? Take note for positive or negative for vector quantities or scalar quantities. Okay? Alright guys, this is for your chapter 1. I'll give you guys the homeworks very soon in our group. I'll post it in PDF form. Hope you guys can do it within 12 hours and submit to me, because esok ada kelas lagi kan, then I don't want you guys to procrastinate and in the end lupa what we learn. Okay? Benda-benda ni sangat penting. It might look very simple. It's continuous sampai you habis syllabus SEM 1. Okay? Alright guys, any questions?
No questions.
So far so good.
Alright. Okay, kalau korang ada apa-apa soalan lepas ni, can just PM me. You guys can PM me your answers in image or PDF form lah. Alright, I'll stop recording right now. And if there's anything you guys want